So today we're going to tackle a simple problem. The question is square root of x bigger than y? And statement A for data sufficiency will give us x is smaller than y. So the way we tackle this, and the way I normally teach that, is we graph the two equations and we see where they overlap and we see the different areas for the two equations. This is a way better approach for tackling these kind of problems, because you don't have to keep testing different points like 0, 1, 2, 3, minus 1, minus 2, and you can always, if you do that way, you can always forget of one part, or maybe a big point is you haven't tested, or you forget about 0, or you forget about the part of the equation that you don't know. In this way you can see it in the whole continuum and you can see it visually. I show you how it works. I have it done the different graphs. So the first thing you do is you graph the equation square root of x equal to y, which is the one that is here. This is square root of x equal to y. And then you think, okay, so they are asking me if all the points where square root of x is bigger than y, and square root of x will be bigger than y, and all the points under that curve that are defined for this formula. So we know that no point where x is negative or y is negative will be defined, because the formula square root of x doesn't support any negative numbers. So we know we'll be kind of in this area under the curve. How do we test that? The way you test that is you think of a point, for example here, which is x is 1 and y is 1/2. Imagine this point, right? So if you put 1 in the x, square root of 1 is 1. And that is definitely bigger than 1/2. So this formula will suffice. So all the points under the curve are the ones that are defined are in the question, and they are asking you, can statement A give you information about points that always allow you to answer yes to this question, or always allow you to answer no to this question? So let's graph statement A. Statement A is a simple line which you graph x equal to y. I have it here. It's a line, 45 degrees slope. It goes through 1, 1. That should be pretty basic for GMAT 700. And they're asking you when x is smaller than that. So when is x smaller than that? Well, x will be smaller than that for all the points that are on top of the curve. So literally all the points that are from the line up here, yeah? So from the line up there. And how do you test that? Well, imagine the point 1, 2. I'm going to put it, imagine it will be around here. If you imagine the point 1, 2, x will be 1 and y will be 2. Obviously x will be smaller than 1. So all these points are there. So what happened now? And this is the interesting point. We know that the two curves are touching here in the point 1, 1, and we can see very clearly that it's an overlap between the two areas. One is under the curve and the other one is on top of the line. And the overlap, I'm just going to paint it here in pink, is literally this area. Okay? So the pink area is the one that is creating the problem. Why? Because statement A is telling you take all the points. Statement A is defining all the points that are on top of the line. And if I pick all these points, when I pick the points that are here, 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 and I try to answer the question, I will answer, is square root of x bigger than y? My answer for all these points, I will say square root of x for all these points, let's say for all the points that are defined, it will be, the answer will be no. It's not bigger than y, because the square root of x will be a very small number and the y will be a very big number. For example, for this point, if I try for this point, that is like 1, it's x is 1 and y is 2. If I try for this point, square root of x will still be 1 and this is smaller than 2. So my answer will be no. So the answer on this area will be no. The problem is that the answer in the pink area, if I pick a point here, it will be such that when I do the square root of x, it will actually give me a bigger value than the y that I have for a point here. And we know it because it's under the curve, when we know that square root of x is bigger than y. So for these points, I will have an answer yes. So if the equation A is defining all the area on top of the line, and for some points in that area my answer to the question will be no, and some other points the answer to the question will be yes, this equation A is no data sufficient. So it's not sufficient to answer the question. Sometimes I answer no, sometimes I answer yes. And that's why this is so visual and such a good way of solving data sufficiency problems. Yeah. So when you have information B, you will do the graph of information B, overlap this, and you will do a more complex analysis. But the idea is that by using the graphs, you can visualize what you're doing, and you can literally think on a way to approach the problem on a holistic way. You see it in the continuum and you're not forgetting any value. This is what solves the problems that are on top of 700. If you do it in the normal way of trying 0, 1, 2, 3, that will only get you to 650 or so. But if you want to go beyond 700 and go to top 10 schools, you need to approach the GMAT problems this way. Thank you, guys.